So this is the final product of what we have built. So here is our the cards and the transactions. So here you can change the amount, you can put it to $70, you can put it to $700 as much as you want. Then it is dynamic. Any amount you put is so you can choose this first card, second card, and third card. So our platform is using sample data from the dataset to make sure that it's working properly. So on a real to implement this on a to implement this, you have to work with closely with banks to because of POV that based on privacy of they cannot give you real data so that you'll be able to uh, so that they will be able to protect uh, customers data and details and to prevent identity theft and so on and so forth. So here, let's say we choose this first card and based on transactions and we check out. It tells us that the payment is successful, no fraudulent activity detected, and to send a message to our email. Then so we choose the second card and send a checkout. It tells payment failed and might be a fraud. Please contact your card issuer. So then the third one, checkout is a successful payment. So then here is our based on our front end, here is our blue dashboard. Thank you. A total of 284,807 transactions, out of which only 492 are fraudulent, making it highly imbalanced. The input feature are PCA transformed numerical variables, each of for time, except for time, which shows time since first transaction and amount, which is transaction amount. The target is a binary class variable, including fraud, which can be denoted as 1 or 0. So due to the imbalance of the data, we were forced to either choose in between undersampling or oversampling the data sets. So we came up with the idea of undersampling the data set. So after undersampling the data set, we came up with the equivalent number of fraudulent and non-fraudulent transactions as equal to 984 transactions total. The project aims to build a big data analytics system that can effectively analyze this imbalanced data to identify patterns specific to fraud case by leveraging technologies like Apache Spark, Impala, Hadoop, deep learning algorithms. The goal is to detect fraudulent transactions accurately despite the reality of positive cases. So this is the dataset. This is the time, the number of seconds elapsed between the transaction and the first transaction in the dataset. This is the PCA dataset, which is from V1 to V28. Then this is the amount, the transaction amount. Then here is the class, which is denoted as 1 for fraudulent transaction and 0 for otherwise.
Our data analyst was assigned the task of analyzing the data and finding out basic and good information about the data sets. So first of all, he reported that based on the dashboard provided here, because all this here it gives us the amount of fraudulent transactions, which is 492, and the non-fraudulent transactions, which is 284,315 non-fraudulent transactions. So this is showing us the imbalance in the data. So this was what the model, the artificial intelligence, like the model trainer used to determine whether to undersample or to oversample the data. So here is the transaction, the amount that was lost to fraudulent activities and the ones that were transacted for under non-fraudulent transactions. So this is the color of fraud is blue and yellow is for these three charts only. So here if you look at this data, we observe a very unique interpretation of what is going on when it comes to the amount, the fraudulent, the amount that is being withdrawn via the fraudulent transactions. Then we notice that the fraudulent transactions don't exceed a certain amount, which is it doesn't exceed uh, it doesn't exceed $2,126, but the non-fraudulent transaction can be as much as $25,000. So for the fraudulent transactions, we are at as an interpretation as shown by the data is telling us that the fraudulent transactions has a maximum of 2,120, telling us that the fraudsters do not withdraw large sum of money to avoid suspicion, but this is what the data is showing us. Some go as low as withdrawing $1 or two. So then our main relationship, that is when you this is main VX, that is the future engineering. Then our main relationship, this is not actually telling us too much.
PySpark, that is the Python library that helps us to communicate with PySpark, and here we should import Spark session. And from PySpark.ml we imported pipeline, and from pipeline.ml.classification we imported random forest classifier, which was the machine learning algorithm used to predict the model. Then from PySpark machine learning evaluation, we imported the multi-class classification evaluator for evaluating our model and to know how accurate or how the precision is. Then the PySpark.ml we imported the pipeline model, and from the PySpark SQL functions we were able to import the mean, standard deviation, variance and some for the future of engineering. Then here we started the Spark session. After starting this Spark session by assigning an acronym to it, we loaded the data. Then we used this JFS, uh, that is Hadoop distributed file system, to access the credit card.csv, so which contains the PCA data and with the time, class and amount. So here we clean the data. So on while cleaning the data, we dropped the none, that is we dropped the null values on all of these columns. Each rows has a null value should be dropped. So under here we now assigned our PCA data list. So this our PCA data list was initialized to make the code shortened. Then we underreported due to data imbalance. So how we did that is we assigned the fraud data frame as this, because this is the lower value, the lower number of rows with the fraud, that is 400 and around 492, and the non-fraudulent data frame should be the we should get the only a number of this. Then our data frame is to combine the fraudulent and the non-fraudulent, making them a combination of 984 and amount data sets. So this here we now get to our feature engineering. Our feature engineering is where we assign features to make the data more meaningful. So here we got a feature named mean, sum, amount category, standard deviation, and variance. So what the mean does is that it combines the means of this PCA variable, that is V1 to V28. So it will get the mean and store it inside the variable in a column inside the data frame named mean V. The same thing with the sum, the same thing with the standard deviation, and the same thing with the variance. But for our amount category, we say that if the amount is less than 50, you should assign 1, and when it is less than 20 but greater than 50, you should assign 2, and if otherwise, you should assign 3. Then here we now come to the training and the evaluation of the model. First of all, we have to split our training and testing data. We did split the training data set to 70, 30, that is 0.7, 0.3, which is equal to 1. We did a random split. Then here we now said, uh, we now did we assigned our model algorithm, which is a random forest classifier, and then the pipeline, we assigned the pipeline. Then our model was now trained using this pipeline.fit, then the training dataset, which is this. Then here, after training, we now use the model to predict the test dataset. Then we now have an evaluator. Then the evaluator was now assigned as the multi-class classification evaluator. This multi-class classification is a class, while also the random forest classifier is also a class. And this was now used to predict this evaluator that evaluates these predictions, that is based on what it was that was predicted, we should be able to determine the accuracy. So here it will now print the test accuracy equal to this. So here we will now say model saving logic, because after training we need the most accurate model. So we will now assign the previous accuracy as 0. But if there is an existing model there already, you should load it and evaluate the model, then assign it to the previous accuracy, which is initialized at 0, and it might now increase to like 60, 70, 80, 90. Then it will now do, if the current accuracy, which is this, is greater than the previous accuracy, then you should print the new model is more accurate, saving model to HDFS. It will now overwrite and save to this uh, model, then else it print this. So I'm ready. So now we now created a class application. So now we created a class application. This application has a blueprint that will help us enable us render our templates and also do other things like send requests. So now this is our home page, that is our index.html, which is located in this part of the template file, index.html. So this was designed by the backend developer, and the model, which is this, was provided. This RF model was provided to the backend developer that developed the Flash application. Under this, we have then we now have the route. This route is where the request will be sent to get uh, this is where it will request to get the the transaction status, if it is fraudulent or not fraudulent. So what does uh, the route do? What it does is that it gets the card, it filters the data and removes the type, the card number, the zip code, and everything. then and it now processes only the PCA data from the cards. That is, it gets the time, it gets the V1, the V2, up to V8, and the amount the person purchased. So then from key in, then here we, because of the type of value sent from the front end, it is not a float or number, so we have to force the data types to convert to float. Then from there, we now converted it to data frame. Then after that, we now initialize the PCA values. Then we now got the name, the sum, the then we also worked on the amount category, worked on the standard deviation, the variance. Then for testing, we pre-tested the new data frame. That was for debugging, but not for production. Then our prediction, we predicted the data frame. Then we now say we now initialize the data frame. So we now say if prediction is equal to 1, meaning that if the prediction was false, that is, if the transaction was a fraudulent transaction, then we can now say that the sender email, which is our test email.gmail.com, and the sender password, then the recipient email, which is this. Then if the subject is cat status, then the body is that this transaction has been flagged as a fraudulent transaction and will be reported to the responsible bodies for further investigation. Then we will now send the email to the card holder. Then we will now return the string. So we returned this for testing purposes. This is actually not uh, going to run as far as it's a post request. It will run only that. This is for testing to know if the API is actually working. And then this is the function for the email, for sending the email. So after that, so after this, we'll now uh, go over to the front end part of the app. So this front end part of the app was designed using HTML5, CSS3, and JavaScript together with frameworks like Bootstrap. So here, so now this is the front end, that is HTML, CSS, and JavaScript part of the code. So we linked external Bootstrap CSS just to make it easier for our coding. So and we linked a Tableau uh, code to embed our Tableau into our program, that is the interface. So here we have the title, which is fraud shield, and here we these are the animation that pop up, that is payment successful and payment failed, that is for the dashboard. So this is our order tab, that is the checkout box. Then here is the script where we have our card details and the transaction details. So we now said we have our event listeners and we have our functions all together in the same code. So this initialize is to initialize our Tableau dashboard. Then we'll now, this is functions to update total, this to render the card options. So this is basically our HTML. So this event listener is when we enter an input, it will calculate the total amount for the checkout and store it. Then here is our radio button. This will keep track of the selected card, and the checkout button has an event listener that will enable us uh, know when we click on the checkout link, we now send a fetch request to our local Flags server with the API post request to card bread, which is a post request to card bread. Then, if the response data is equal to 0, we will now show the failure animation. That is, we will hide it and we'll show the success animation. But if it's equal to 1, we will hide the success and show the failure animation. This is basically how it works. So now we'll go to the next. So this is the final product of what we have built. So here is the cards and the transactions. So here you can change the amount, you can put it to $70, you can put it to $700 as much as you want. Then it is dynamic. Any amount you put so you can choose this first card, second card, and third card. So our platform is using sample data from the dataset to make sure that it's working properly. So on a real to implement this on a to implement this, you have to work with closely with banks to because of POV that based on privacy of they cannot give you real data so that you'll be able to uh, so that they will be able to protect customers' data and details and to prevent identity theft and so on and so forth. So here, let's say we choose this first card and based on transactions and we check out. It tells us that the payment is successful, no fraudulent activity detected, and to send a message to our email. Then so we choose the second card and send a checkout. It tells payment failed and might be a fraud. Please contact your card issuer. So then the third one, checkout is a successful payment. So then here is our based on our front end, here is our Tableau dashboard. Thank you.